Hello again everyone, welcome back to ptet.chemistry channel. So this is a continuation of the MCQ work that's associated with the mole calculations and stoichiometry concepts for the year 9 5070 or any related IGCSE curriculum, which basically is the 14 to 16 years old curriculum, and this is regarding mole concept, which is suitable for any 14 to 16 years old all around the world if you are doing the pure science stream curriculum. Let's get started with this MCQ. So in this first question, so we're told that these two equations are the two stages in manufacturing fertilizers such as ammonium nitrate. This is ammonia, oxygen, nitric acid, water or steam or whatever, H2O, nitric acid, ammonia, ammonium nitrate, because this is a base and this is an acid. The problem when you have NH3 acting as the base is that you don't produce water because you don't have enough atom to make the water. Ideally speaking, the NH3 will be present in a little bit of water as ammonium hydroxide, then you will produce water to balance the equation. Now you want to start from 17 tons of ammonia. So this is mass, we are dealing with tons. 1 ton is equal to 1000 kilogram, and of course 1 kilogram is 1000 gram. In this kind of question, we are dealing everything in tons, so we really don't want to be working on such a 10 to the 6 kind of scale, because 1 tons is 1000 kilogram, converted to gram is multiplied by 1000. This is 10 to the 3 kilogram. This is 10 to the 3 gram, so 1 ton is going to be 10 to the 3 times 10 to the 3 gram. 1 ton is 10 to the 6 gram. This is the kind of mathematical conversion or things you have done in physics very easily. Now I want to know the maximum mass of fertilizer. My fertilizer is ammonium nitrate because they say fertilizer ammonium nitrate. They give me the MR, so I can save time on that, and also the MR ammonia because I'm supposed to do a calculation involving ammonia as well as ammonium nitrate. If I start from 17 tons of ammonia, then I'll get however much of HNO3. But remember that ammonia is involved in 2 stages, so you cannot just think about one stage. If I were you, I would really be combining the stage together so that it will make more sense in the overall equation. So I'll have 2 NH3 plus 2 O2 plus HNO3, and I'll produce HNO3 plus H2O plus NH4NO3. Now we can very clearly see that HNO3 and HNO3 appear on both sides of the equation. So realistically speaking, the HNO3 is present in the multi-step reaction, but I don't really need it in my overall equation because that would just make my life complicated in my kind of like mole calculations kind of setting. I just want to keep things simple and whatever that makes sense of it. So that is my overall equation, the balance equation that I can use for my mole calculations, because now I can see it's not just 1 mole ammonia there, because the second step also use another mole ammonia. I have 17 tons of ammonia available. I want to know the fertilizers, the maximum mass that I can get out of it. So my mole of ammonium nitrate as my fertilizer over my mole of NH3, which I have made available as my reactant. So 1 mole of ammonium nitrate from 2 mole of ammonia, 2 mole ammonia, 1 mole of ammonium nitrate on top from the balance equation. Now I'm given masses, I'm working with masses, and I want the mass of fertilizer, so I will be working with mass of the NH4NO3. I suppose if this is in tons, then the mass of ammonia over the MR ammonia will be in tons as well, so 17 tons over, 17 is the MR, so mass over MR. So this one is in tons, so this makes sense for this to be in tons because the unit conversion will cancel out, so I don't really need to convert that to gram at all, and I need to divide that by the molar mass, which is this one, 80. So hopefully you can see then you just need to make the mass of the ammonium nitrate as your subject of formula. So what we could get then is the mass of ammonium nitrate. This would be in tons, so bring this up. So 1 over 2 times 17 over 17 times 80, and you can get the answer as 40, not kilogram, but 40 tons. Alright, so you can press that onto your calculator. 0.5 times 17 over 17 times 80, which will give the exact answer which I've done, because I could see the 17 and 17 does cancel out, because 17 by 17 is 1, half of 80 is just 40, and we have defined that to be in tons because this was in tons, so I've gotten my answer there. Moving straight into the question 2, what is the total mass of the solution that remains? Okay, so you want the mass of the solution that remains. It's very important that this is the gas that escaped. If I work out the total mass here, so I know this is 40 gram and I know this is 100 gram of water. So my conservation of mass says that the total mass here must be 40 plus 100, which is 140 gram. So altogether, I'm expecting 140 gram on the right hand side, because this and this add up together to the total mass. Of course, the H2 will escape, so really I should be working out the mass of H2, and therefore the total mass minus the thing that escaped will tell me the mass of the solution that remains. So this question is really asking me the mole of H2 over the mole of calcium. This is a tricky one, because how do I know which one fully reacted? I don't know that unless I work out the mole of calcium and the mole of water. So the mole of calcium, mass over mR, or in this case mass over AR, because it's an element. So I gotta use the relative atomic mass of 40 over 40, that is 1 mole. And then my second step, the mole of the water. So I hope you know the relative molecular mass of water, 2 times 1 plus 16, that give you 18. And you started with 100 grams, so 100 divided by 18, that give you 5.6 mole. So hopefully you can see that 1 mole of calcium needs 2 mole of water. 1 mole of calcium only requires 2 moles of water. Therefore, this one is in excess. We do not use the thing which is in excess for our calculations, so we'll use the mole of calcium for our calculations when we compare mole ratio. So let's compare our mole ratio. The mole of H2 is to the mole of calcium. Because calcium is limiting, it's completely used up because this is in excess. Let me see what I can do. So on the right hand side, I want the mass of H2 because I want to work out the mass of solution that remained. It's better if I work out the mass of H2 that escaped and then I just take away from 140. It's a lot easier. Mass over mR, because H2 exists as a molecule. The mR of H2 is 1 times 2, that's 2. At the bottom, I have 40 gram of calcium. Well, actually, I know the mole already. 40 over 40 is 1 mole, so it's just 1 mole. And I forgot to do something. I forgot to compare from the mole ratio. The mole ratio from the balance equation is actually equal to 1 mole of H2 is to 1 mole of calcium. So 1 over 1 is equal to that over that. Find the mass of H2. You get 1 over 1 times 2, which is 2 gram. Oh, that's very light. Yeah, I mean, there's just 1 mole of calcium, give you 2 gram of hydrogen. So move that 1 up, move that 2 up, you get 2 gram of hydrogen. So therefore, the mass of solution remaining, the mass of solution that remains is going to be the total mass, 140, minus the 2 gram of hydrogen that escaped, you're going to get 138 grams. So be very careful what we are thinking about, yeah? Question 3, hydrogen reacts with oxygen as per this equation here. If you react 2 dm cube of hydrogen with 1 dm cube of oxygen, so this is mole, it's 2:1, but these are gases because it's given for you as gases. So if you have 2 dm cube, they will also react with 1 dm cube. So this is a liquid, not gas. So 2 mole of gas will react with 1 mole of gas. 2 dm cube of gas will react with 1 dm cube of gas based on the mole ratio, because both the gases will have the same molar volume of gas, which is 24 dm cube per mole. So what we're going to get is we will not get any gas remain because the gas will be completely used up in the 2:1 stoichiometry, or what we call mole ratio. Volume ratio of gas is the same as mole ratio of gas. This is not a gas, you don't get any gas remaining, so it's 0 dm cube. Quite a confusing question there. Next question, this is also quite confusing. The formula of sulfuric acid is H2SO4. In 1 mole of sulfuric acid, there is 2 H+. very important that I should really move that equation down there. In one sulfuric acid, I have 2 H plus and I have 1 SO4 2 minus. So if I have 0.05 mole per dm cube, remember that these are in the same volume, all in the same volume. They are basically from the same solution mixture where they just dissociate into H plus and the SO4 2 minus. So if there's 0.05 mole per dm cube, therefore you have 2 times 0.05, which is 1.0 or 1.00 mole per dm cube. Now this is of H plus, but be very careful, they 1 gram per dm cube. This is the concentration of H plus in mole per dm cube. We know that mole is equal to mass over mR. If you have mole per dm cube, you just divide by dm cube both sides. That is how I always remember this formula. You're gonna get gram per dm cube because we're just dividing both sides by dm cube, so nothing has changed at the bottom. So the top bit is the mass of the dm cube and the bottom bit remains exactly the same, so it's gram per mole. So I've written this in the form of -3, but it actually means the same thing, gram over dm cube, gram over mole. This is just your mathematical expression. So in the end of the day, so we have 1 mole per dm cube on the right hand side. So 1 mole per dm cube. And we want the gram per dm cube. And we have for H plus. So our MR is going to be 1 because for H plus, which has lost 1 electron is very light. The mass is pretty much the same as, well, the relative molecular mass or whatever you call it for H plus is going to be exactly the same or very close to that of a hydrogen atom. So meaning to say our gram per dm cube, meaning our mass concentration, this is called mass concentration of H plus is going to be 1.0 gram per dm cube, which means our best answer is going to be we don't have a best answer here. I wonder why. I know why now. I have done a mistake for this all the way around. So 0.05 times 2 should have been 0.10, which means this should have been 0.10, which means this should have been 0.10. So this is a perfect example of, one small mistake they get carried all the way through. If this is a structured paper, I would have gotten 0. Okay, this is very luckily a multiple choice paper, so I can know that this is one of the options given, so I didn't get 1.0, so I know this must be the answer here. In the next solution, so this is about iron 3 sulfate, which contain iron 3 plus SO4 2 minus. Iron 3 sulfate is going to be, well, if I show you how to get the formula, iron 3 plus SO4 2 minus, as I say, plus 3 and minus 2. You're supposed to know how to get this formula. These are lowest common multiple. We look at the value associated with the charge. We cross multiply the value of the charges because there's lowest common multiple. We do not cross multiply the ion. We do not cross multiply the charge itself. We cross multiply the value, which is 2, the value of which is 3. This means 2 Fe3 plus. This means 3 SO4 2 minus. So SO4 2 minus as well as SO4 2 minus. And therefore the formula we are looking at for iron 3 sulfate would be Fe, well, if I just summarize it straight away, so this is going to be Fe2 SO4, 3 of them. So it cannot be this, it cannot be that, so A and B are out. We're looking at C and D. I'll tell you straight away without looking at them, they are exactly the same. So how in the world do I know which one is correct? The next thing I look at is this thing, the stat symbol, aqueous and liquid. They say a solution. Solution means dissolve in water. So it's not a liquid, it's a solution. Liquid would mean you melt the giant ionic structure because it consists of ions. So you are not going to melt this giant ionic structure unless you have very high temperature. A solution is a mixture, it's an aqueous solution. Without needing to balance the equation as these two are the same, I just need to look at the stat symbol. Question 6. So they're asking for which volume of gas be very, very, very careful. This is a gas and this is a gas. So I can imagine that this is 5 moles of gases. All right. So I have magnesium nitrate, which is this. So I can think about my molar ratio, the mole of gases, for example. You have seen this in one of the previous work associated with mole calculation. That was, as well. They were talking about mole of gases. So here there are two gases, NO2 and O2. 4 plus 1 give you 5 mole of gas. 2 moles of magnesium nitrate. On the other side, we do this thing combining the moles gases because gases will have the same molar volume. So I will have volume of gas, and they are at, well, they didn't say room temperature, but we can assume it at room temperature and pressure, where the molar volume is 24 dm cube per mole. So the volume of gas will be in dm cube, and that's the option given in the question. And the other place will be 0.1 mole of magnesium nitrate, because it's already given as the actual mole, so I don't need to do mass over mR. This is just mole of magnesium nitrate, subtract in for the actual mole. Rearrange your equation. The volume of gas is going to be, move that up, so 5 over 2 times 0.1, move the 24 up there, so times 24, press down to your calculator, so 5 over 2 times 0.1 times 24, I get 6. This is what your calculator show you in terms of appropriate number of significant figure. It seems all of these follow 1 decimal place, which follows the data given there. So sometimes it's decimal place, sometimes it's significant figure. This is very clearly 1 significant figure. This is very clearly 2 significant figure. So just be learning along the way what is appropriate number of significant figure. The next question, so you have 100 kilogram bags. Doesn't matter what the total mass is, they all have the same 100 kilogram. So which one is the greatest mass of nitrogen out of the 100 kilogram? So the first thing we should really be thinking about is to work out the MR. So the MR, as you know, is just sum up the individual relative atomic masses. It's one of the exercise that you have done previously. So it's 14 for each nitrogen, plus 4 times 1, plus 14, plus 16 times 3. That give me 80. And you could do the same thing here, but be very careful. There are 3 of the ammonium, so I'll probably be based if I have 3 times whatever is in the bracket. So 14 plus 4 times 1, they give me 18. So 3 times 18, or 18 times 3, plus 31 for 1 phosphorus, plus 16 times 4. Just to be safe than sorry, because you never know how certain mistakes can come about when you press button incorrectly. As for this, you have 2 times 18, because here you have 3 of the NH4 plus, 3 times 18. Here you have 2 of the NH4 plus, so 2 times 18, plus 32 times 1, plus 16 times 4 for the SO42 minus. 2 times 18, plus 32, plus 16 times 4. So then I get 132. Last but not least, I have 12 plus 16. Plus 2 times 14 plus 2 for the NH2, and I've got 2 of them, so that is 14 plus 2 is 16. So 12 plus 16 times 2, I get 60 altogether. Let me just double check in case I make a mistake there. Yep, that's alright. So what is the greatest mass of nitrogen? Just like in the previous question, what we can do here is we can work out for A. So there are 2 nitrogens, so 2 times 14 over 80 times 100 kilograms. So that will give us the mass of the nitrogen, because there are 2 nitrogen in the whole formula unit, each of which is 14 out of the MR times 100 kilograms. So 2 times 14 divided by 80 times 100%, well, times 100 kilogram, not percent. So that gave me 35 kilogram. Anyway, we have to work out for all of them because they want the greatest mass of nitrogen, something you won't be able to do unless you work out for all of them. 3 nitrogen, so 3 times 14 over 149 times 100 kilogram. I get 28.2 kilogram, something like that. If I work out for C, I have 2 nitrogen again, so 2 times 14 divided by 132 times 100 kilogram. So that is 21.2 kilogram. Last but not least, for D, I have 2 nitrogen, so 2 times 14 over 60 times 100 kilogram. That gave me 46.7 kilogram. The one with the largest or the greatest mass of nitrogen is very clearly the 46.7, so D is the answer there. Question 8, so we have calcium carbonate, metal carbonate plus acid, give you metal salt, water and carbon dioxide. There are 5 general equations as covered in previous lecture tutorials many lessons ago. If you still can't master your general equations, then you're going to be in big trouble when they come to any equations they throw at you. So they're asking you they give you calcium carbonate information, they give you HCl information. They want to know what is the volume of the CO2, which is a gas. This question is really trying to trick you. Which information do you use, this or this, to work out the volume of carbon dioxide? You really must work out which one is limiting, which one is completely used up, meaning limiting, and which one is in excess and not completely used up. So let's try these. These are given as mass, reacting mass. This is reacting concentration as well as volume because it's a solution. N equal to CV for solution, N equal to mass over MR for reacting mass. So the MR of calcium carbonate, straight from the periodic table, 40 plus 12 plus 16 times 3, they give you 100. So therefore, the mole of calcium carbonate is mass over the MR, so it's 1.00 divided by 100. That gives me 0.01 mole. The second bit, N equal to CV, well, N of the HCl is equal to CV, concentration in mole per dm cube. Very important that we know is mole per dm cube, multiplied by the volume. So I'm going to divide by 1,000 to convert that to dm cube. I get 2.5 times 10 to the minus 3 mole. This number might look alien to you, but if you convert it into a decimal place, you should know how to do that on your calculator. You gotta know how to do it on your calculator very easily. So let me see. So that is 0.0025, am I correct? So that is 1, 2, and 3. You should be able to do it on a calculator. Anyway, so we know 1 mole of calcium carbonate reacts to 2 mole of HCl. So how do we decide? So therefore, 0.01 mole of calcium carbonate needs, well, 2 times of the HCl, so 2 times 0.01 equal to 0.02 mole of HCl. How much do you have? You have 0.0025 mole, which is much lesser than what you need. So this is completely used up. This therefore is in excess. So therefore, this question is a bit tricky now. So therefore, HCl is limiting. Limiting reactant is defined as something which is completely used up. So we use that for our calculation. In terms of our calculation, let me see if I can move it somewhere else. If I can move it a little bit up there. Space are a bit limited now. So the mole of CO2 over the mole of HCl is 1/2. Is the volume of CO2 over 24. I shouldn't use 24, I should use 24,000 because if you look at the answers given, cm cube, I should assume the volume there is going to be in cm cube, therefore I use 24,000 cm cube per mole. The volume of the gas is 24,000 cm cube for 1 mole per mole for 1 mole of the gas, divided by the mole of the HCl, which is 0.025 or 2.5 times 10 to the minus 3 as previously calculated. So hopefully you should be able to rearrange that equation. I will leave you that as an exercise to do. So you bring up the 0.0025, then times 1/2, times 1/2, and then times 24,000, and you should get 30 cm cube. Because we have defined it in cm cube, that's why we use 24,000 cm cube per mole as the molar volume of gas. Question 9, this is not calcium carbonate with acid. This is just thermal decomposition. This reaction is called thermal decomposition because from one substance, it decomposes, it breaks up into two things, and this happens in the presence of heat. Thermal means heat, you heat it and it decomposes. Thermal decomposition group 2 carbonate is a very common chemistry that you will experience and see again later on when you come to group 2 chemistry. So we are dealing with kilogram of calcium carbonate, and the yield we get is 85 kilogram. They want to talk about percentage yield. So we got to think about this is actual. So how much do we expect actually from 225 kilogram calcium carbonate? So calcium oxide, right? So the mole of calcium oxide is to the mole of calcium carbonate is 1:1. So how much mass of calcium oxide do we expect? Well, we need the MR of calcium oxide. So 40 plus 16, that gave me 56 from the periodic table. Mass over MR, that's going to be the mole of the calcium oxide. And then I have my MR of calcium carbonate, which you can calculate from the periodic table again. MR of CaCO3, I've done it a couple of times previously. You should be able to get 100 very easily. 40 plus 12 plus 16 times 3 very quickly. So there's 225 kilogram divided by 100. Why in the world did I not convert this to kilogram? To gram, because this is in kilogram. So this is in kilogram. As we have encountered previously, I think in work, well, somewhere between work 1 to work 6, which you will have done completely on your own, which you will have gotten feedback on, which you will have understood why, if this is in kilogram, this has to be in kilogram. For the mass conversion, you need to cancel out. Mass over MR for the reacting mass to get the mole of the solid. Mass over MR for the reacting mass to get mole of the solid. So the mass of the calcium oxide based on the 1:1 mole ratio is a theoretical 100% reaction. So it's 225 over 100 times 1/1 times 56. So they gave me 126 kilogram. Remember, this is theoretical. This is expecting 100% yield. So this is 100% yield. So therefore, if this is step 1, therefore the percentage yield, how much do you actually get? You only get 85 kilogram. You expect 126 kilogram, but you only get 85 kilogram in reality. So 85 divided by 126, the kilogram and the kilogram get cancelled out because that's what the units, they are the same, they get cancelled out, and now your unit is percentage. 67.5 is option C there. Number 10, we see another thermal decomposition. Here you want to make 5 grams of magnesium oxide. So the MR of MgO is 24 plus 16 from the periodic table. They gave me 40. Magnesium carbonate, so the MR of MgCO3, formula of which is given, but you gotta know Mg2 plus CO3 2 minus. 24 plus 12 plus 16 times 3 give you 84. We could see 1 mole give you 1 mole of MgO. So the mole of MgCO3 is to the mole of MgO. Really does not matter which way around it is, as long as you follow the bookkeeping. If I put this on top, so it's 1 mole there. If I put this at the bottom, I follow whatever I have written down, like that. Whatever is on top is for the MgCO3. So that is the mass of the magnesium carbonate. So the mass of the magnesium carbonate, mass over MR. So mass over MR of that substance will give me the mole of that substance. At the bottom, there is your mass over MR for the MgO. I want to make 5 grams of this magnesium oxide, so there's 5.0 divided by 40 there. Again, what you do then is you do not use equal all the way, because you got to make this the subject. Ideally speaking, I should do it down there, but I'm running out of space, so I just use this arrow to indicate the next step. But I don't use equal, because equal would have meant that I don't make that the subject. They are just used incorrectly if you use equal there. Okay, so I move this up there and then multiply by 84. Hopefully you can see the math fairly easily. If you can't, I would say do it step by step, but at this stage you probably have done enough that you should be able to do this directly. If you cannot, then you need to go back to the previous step, to the previous work, and try and master those particular concepts. Next one, we have this particular gram. This is mass, this is MR, these are mole per dm cube. So ideally speaking, the first thing we do is what is the mole of the ascorbic acid. I could do this in one step. I just want to show you the mass over the MR because we are given the mass, not because this is the only formula, but because we are given the mass. So we have to think about reacting masses and the MR like that. You got to think what you want to do before you actually do it, okay? So you can evaluate the answer. I mean, give me a lot of decimal place, 5.4545 times 10 to the minus 4 mole. You got to learn to read this on your calculator. Don't bother to convert it to decimal. It's all right. You got to learn to read it from your calculator. You got to learn to write it. You got to learn to type it into your calculator because it's very important to do this in math as well as physics. Now I want the concentration. Concentration is going to be mole over volume because N equal to CV, so C equal to N over V. Mole over dm cube. Mole, and the volume has to be in dm cube. My mole is 4.545 times 10 to the minus 4. And then my dm cube, this is in cm cube, so convert that to dm cube. I'm going to try this format where I do times 10 to the minus 3. cm cube to dm cube at times 10 to the minus 3 is the same as saying 200 over 1000 dm cube. So this is mole, this is dm cube. That doesn't work out. You need to evaluate and give a value on your calculator. So they gave me 2.27 times 10 to the minus 3 mole per dm cube. So 2.27, so rounded up, that would be 2.3 if we round it up to one decimal place there. Question 12, what do we have in question 12? Oxide of nitrogen, percentage composition by mass. This percentage add up to 100%. That's because you only have two substances, N and O. If you think about the mass per 100 gram, because these are percentage add up to 100%, just like your percentage in an exam or in a test. So this is out of 100 gram. These are the percentage by mass. So out of 100 gram, you have 30.4 gram of oxygen, and you have 69.6 gram of, oops, I got it the other one. You got 30.4 gram of nitrogen, and you got 69.6 gram for the oxygen. What we do next is we do mole. Mole equal to mass over AR because we are trying to work out, first of all, empirical first. Yes, they're asking for molecular, but you do not get molecular unless you can get empirical first, all right? So empirical is your first step. Empirical formula is defined as the actual number, not actual number, but the simplest ratio of atoms in the compound. So 30.4 over 14, evaluate that. Do not just leave it like that because that's not one of your steps. So evaluate it. So 69.6 over 16. So they give you 4.35. You do not run up from here because what you want is the simplest ratio. Simplest ratio means that you have to divide by the smallest number to try and get to the simplest ratio. So the simplest number is 2.17 divided by 2.17 is 1. 4.35 divided by 2.17. So they give me 2.00. Then I can run up to 2. So that is my first step. My second step says empirical formula. The MR or empirical formula times a certain factor, let's say y is equal to MR of the molecular formula. That is the conversion factor. How many times of the MR of empirical formula, which is NO2. There's the empirical formula. So you have 14 times 1 plus 16 times 2, that's 46. So 46 for the empirical formula. 46y is equal to, this is MR because it's molecular formula. That's 92. The MR of the molecular formula as stated in the question very, very clearly. So therefore, molecular formula is NO2 2 times. So it's N2O4. All right, so this question is a bit tricky. They don't tell you to find empirical first, but given this, you don't work out the molecular without being able to work out the empirical first of all, and very, very quickly, all of these within 1 minute. Question 13, which gas sample contains the most molecules? So the number of molecules is actually equal to the number of mole of the molecules. How many mole you have of the molecules times the Avogadro constant, which is 6.02 times 10 to the 23. There was a lecture tutorial associated with this a long time ago, which you will have done the examples, which you will have completed the work, which you will have received the feedback, which you will have learned how to do it on your own. So on this question, so we're given the volume of a gas. So the first thing we do is we work out mole. We work with mole. The one with the greatest mole will give us the greatest number of molecules without us multiplying by the Avogadro constant and making our life tricky. This is 24 dm cube. You divide by the molar volume. This is dm cube. At the bottom is dm cube per mole, because that's the definition of molar volume. It will give you 1 mole. As for B, you're given mass. So therefore, if you're given mass of the H2, I have to use mass of Mr since I'm given the masses. Mr is for the molecule, because the question says for the molecule, the Mr of H2 molecule is 1 times 2, so they gave me 2 mole. Part C, I have HCl as a gas. Hydrogen chloride, simple molecular structure from your structure and bonding, one of the 12 simple covalent molecules I asked you to draw. Some people have submitted, some people haven't submitted. So volume divided by the molar volume. So just like in the first case, option A there. So they give me 1.5 mole. And D, last but not least, you have the mole of N2, given the mass 14 gram divided by 28 because of the molecule 14 times 2, so it gave me 0.5 mole. Because this is the greatest number of mole of the molecules, this will multiply by L, and therefore this will give the most number of molecules. The answer there must be B. Number 14 is like this previous question, but in reverse order. You want the greatest mass. So if we have mole is equal to mass over Mr, so what do we have? Mass equal to mole times Mr. So rearranging this equation, move up the Mr times the mole. Well, let's work out the Mr. Mr of A is Cl2, so 35.5 times 2, they give me 71. O2 is 16 times 2, they give me 32. N2 is 14 times 2, they give me 28. And last but not least, H2 is 1 plus 1, which is 2, or 2 times 1, which is 2. So what I do is mole, 5 mole times 71. I can do 10 mole times 32, 15 mole times 28, and then 20 mole times 2. Well, let's start from the very top. 71 times 5, they give me 355 gram, because this is mass in gram. Alright, so 10 mole times 32, that is 320 gram. So masses have units, yeah, be very, very careful about your physical quantity. Someone who cannot do units means that you will have extremely big problem when it comes to physics. Greatest mass has to be answer C there. Question 15, so we have this is very similar to something we've done previously. This is really about mixing two things together, but you're not sure that, are they reacting in 2:1 ratio, or some of them is in excess, one of them is limiting. So we really must check. And therefore, because you need to check in order to make sure that, you get it right. The volume of carbon dioxide gas is based on calculation. You must use whichever one is completely used up, whichever one is limiting. So the mole of HCl is 25.0 times 10 to the minus 3. To convert it to dm cube, you divide by 1000, which is the same as times 10 to the minus 3. Something you would have known because you have watched my other tutorial and you have done the feedback and the corrections, of course. All right. Now the next bit is the mole of the calcium carbonate. The mole of calcium carbonate is mass over Mr, and your mass is 25.0 gram. The Mr of calcium carbonate, you can work out from the periodic table. 40 plus 12 plus 16 times 3, they give you 100. And therefore, just 25 divided by 100, I get 0.25 mole. From this equation, 1 mole of calcium carbonate requires 2 mole of HCl. This is what you do. 1 mole of this needs 2 mole of these. Alright, so what I can do is, therefore, 0.25 mole of calcium carbonate will need 2 times 0.25, because 1 of calcium carbonate, 1 of these require 2 of it. So if you have 0.25 of this, you need 2 times 0.25, which will give you 0.50 mole of HCl. How much you actually have? You have lesser than this. Therefore, this is completely used up because it's much lesser than what you need. It's lesser than what you need, so therefore this is completely used up. All right, so sure you're working like this. Therefore, HCl is used up, i.e. we said that it's limiting. And because HCl is limiting, we got to use HCl as our calculations to work out the volume of gas there. I'm just going to continue up there. Let me change the color of the ink. So step 3, the mole of CO2. HCl is limiting, as I said. So the mole of CO2 is 1 mole of CO2 comes from 2 mole of HCl. I want the volume of CO2. Each of these is in dm cube. Because it's given in dm cube, I can divide by 24 because there's the 24 dm cube per mole for the molar volume. At the bottom, I have the mole of HCl, which is limiting because it's completely used up. So I just put in 0.025, which I already did in the previous step without having to do it again because I don't have so much time to spare at all. That is not complete, so what I need to do is I bring this one up times 1/2, so I'll bring that one up and then times 24 again. So don't forget to express your subject of formula first, rearrange your equation first before pressing your calculator. Only press your calculator in the last step because you know you will make a mistake if you do it too early on and you're not focused on making this one the subject of formula there. Number 16, iron can react with sulfur. You get 2 ionic compounds. The iron is present in Fe2 plus in one compound, Fe3 plus in the other compound. So, well, you know, iron 2 plus, S2 minus, plus 2 minus 2. You can bring down the numbers 2 there become 2, the numbers 2 there, just cross multiply. You want the simplest ratio. As you could also see that the charges already cancel out, plus 2 and minus 2. So you just need one of the iron 2 plus and one of the S2 minus. On the other hand, if you have iron 3 plus, S2 minus, plus 3 and minus 2, the value of the charge is is 3. Alright, so you never cross multiply the ion. You never cross multiply the ion, you never cross multiply the charge, you cross multiply the value because you are doing lowest common multiple, which is primary school mathematics. The thing on the left there 2 means 2 pieces of Fe3 plus. So Fe3 plus, Fe3 plus, and then you have 3 of the S2 minus, like that. So altogether what you have is Fe3 plus, 2 of it, and S2 minus 3 of it. So there's Fe2S3. And looking at the answer there, Fe2S3, Fe2S3, FeS is the correct answer there. 17, so what do we have here? They say potassium sulfate, they talk about moles, they're giving us the masses, talk about magnesium chloride as well. So I think one of the first thing I need to do is work out the MR. Do not just write MR without labeling your stuff. Otherwise, you'll be just repeating whatever you're doing. So K2SO4 because it's K plus and SO4 2 minus. So you need 39 times 2 from the periodic table. For the 39 is the atomic mass for potassium. So 39 times 2 plus 32 times 1 plus 16 times 4. I get 174. The MR of MgCl2, there's 24 plus 35.5 times 2, I get 95. So what do I do next? They say same number of mole, so we know the mole of K2SO4 is equal to the mole of MgCl2. On the left hand side, I'll make it the mole of K2SO4, so 69.6 gram of the K2SO4, mass over MR, mass 69.6 gram, MR 174 for the K2SO4. On the right hand side, I want the mass of MgCl2, mass over MR 95. So altogether now your job is rearrange. I don't use equal again because I have just rearranged the mass of the magnesium chloride. Ideally speaking, if I have space at the bottom, I should continue at the bottom where I rearrange my equation. You probably have a bit more space if you are working on a full-scale paper or also in the real exam. So show you're working very, very clearly. Do not just use equal randomly. Make sure equal is being labeled by something and something. These are masses that have units, so it's 38 gram, and that answer has to be answer C there. Question 18, so we want the formula of the hydrocarbon CXHY. So what can we say? We have excess of oxygen, so that means we don't use whatever oxygen is for our calculation. You get 20 cm³ of carbon dioxide. Water vapor, this is very important because water vapor means H2 or gas. CO2 is a gas because for gases, we know that gases occupy 24 dm³ per 1 mole of gas, because this is the unit for molar volume of gas. 1 mole of any gas occupies a volume of 24 dm³ at room temperature and pressure. So what can we say? If CXHY is also gaseous, so we can imagine CXHY is to CO2 is to H2O. You are just reacting with oxygen, so all your carbon come from the X, because if you have one of these, all your carbon goes to CO2 because you burn in excess oxygen. You are just reacting with oxygen and you just produce CO2 and H2O. There's no hydrogen in here, so all your hydrogen, which is Y number of hydrogen atom from one of these, will give you Y of these, so therefore you must have Y over 2. So this is your mole ratio. But remember that mole of gas equal to volume of gas divided by 24 dm³ per mole, and all of these are gases, so mole ratio is equal to volume ratio. Mole is not equal to volume, but mole ratio equal to volume ratio for gases. That's why it's very important to focus on the gases there. What do we have? We have 10, we have 20, and we have 30. Of course, we want the simplest ratio. So the simplest ratio means you divide by the smallest number. That will give me 1. Divide by 10 will give me 2. 30 divided by 2 will give me, 30 divided by 10 will give me 3. So what can I say? One of these, 1 and 1. So I can compare x equal to 2. So therefore, x equal to 2. I can say one of these and one of these. One give you x CO2 and y over 2 H2O. One of these will give me x CO2, which is x equal to 2. Y over 2 is equal to 3. Not y equal to 3, but y over 2 equal to 3. So y over 2 is equal to 3. Y is equal to 6. So C2H6 is going to be the correct answer. This is algebra, and the only algebra here is comparing mole ratio, where you're comparing coefficient, something very popular in mathematics, and these are based on the idea of mole ratio being equal to volume ratio, because you know something about molar volume of gas, where the mole of a gas is equal to volume of a gas divided by molar volume of the gas itself. All right, not too sure what happening to my pencil there. All right, that looks better. Question 19, let me change the color. So 4 grams of solid sodium hydroxide you add to water, in fact should be distilled or deionized water. You get a solution with this much concentration. So you started from 4 gram NaOH. I love to draw a simple diagram like this. Not a great artist, but you know, now you have NaOH aqueous. You are just adding water, just add water. So that means mole is the same. Your mole is the same because you are just adding water. So the mole of the solid is equal to the mole of the solution, because altogether you're just adding water. So the mole of the solid, I do need the MR of NaOH. Work that out from the periodic table. So there's 23 plus 16 plus 1. That gives me 40. These are solid on the left, so I keep mass over MR on the left hand side because it's for the solid. The MR is 40, the mass is 4 gram, so 4.00 over 40 is the mole of the solid. On the right hand side is the mole of the solution. I want the concentration, I have the concentration of the solid, 0.200. As you know, mole of solution, N equal to CV, concentration of solution in mole per dm³ times the volume of solution in dm³. Each of these is cm³. So I need the volume to be in cm³, and then I divide by 1,000. The volume is in cm³ because the answer here is all in cm³. So think sensibly. If this is in cm³, you must convert to dm³ because concentration is in mole per dm³ times dm³ will give you the answer in mole. Now make volume the subject. So this is just mathematics now. So multiply by 1000 over 0.200. I do not convert anything. I do not compute anything onto my calculator until I can rearrange my equation confidently and correctly. So that will give me 500. It will not be in dm cube because of how I defined V earlier. V is the volume of the solution in cm cube. That's why I divide by 1000 earlier for my expression for model solution. 500 cm cube, the answer is C there. Question 20, so they want empirical formula, something very similar to what we've done before. Fe and O, so we're running out of space very easily here, but anyway, I'll use whatever space we have. Just cut straight to the chase, mole equal to mass over AR. So the AR of iron, I think, is 56. Let me just double check. It is 56, so 50.4 over 56, give a value. Oxygen, there is 21.6 over 16, give a value. Should really find a bit more space down there. Alright, so this is for question 20. Anyway, so 50.4 divided by 56 give me 0.9. 21.6 divided by 16 give me 1.35. Do not run up as FE1 and then O1. You got to take the simplest ratio. This is the most important thing that a lot of students forget. Simplest ratio means you divide by the smallest number, which in this case is 0.9. That will give you 1.35 divided by 0.9. It gives you exactly 1.5. We have a problem now. This is a 1.5. I do not run it up to 2. Instead, what I do is times 2 both sides, because 1.5 is basically 3 over 2. So what you get is 1 times 2 equal to 2. 1.5 times 2 will give you 3. So what you have is Fe, you have 2 of it. Oxygen, you have 3 of it. Fe2 or 3. This is iron 3 oxide. We did naming many lessons ago, because you're supposed to know your ions, you're supposed to know names, you're supposed to know formulas, and you're supposed to know equations, you're supposed to know balancing equations, and then calculations step by step, walk before you can run. So Fe2O3 is the empirical formula. It's defined as the simplest ratio of atoms. That's why we have to do this last step, simplest ratio of atoms in the compound. #21, so empirical formula again. So question 21, use a different ink so that we are not confused by whatever we did. So the sum of the percentage, these are all percentage by mass. So what I could do is I just jump straight molecule to mass over AR. Because it's the simplest ratio of atoms, we have to use atomic mass and not molecular mass. We have to think of these as atoms. Be very careful. That divided by 40, I think, from the periodic table. Yep, AR for calcium. And then 24.1 divided by 28, that's the atomic mass for silicon. And then last but not least, 41.4 over 16. Don't forget to evaluate and give a value as part of your working. Give a value, evaluate. Do not just leave it as fraction like this. Evaluate so you can get a value. 41.4 divided by 16. So 2.5875. You want the simplest ratio of atoms. That is your definition. If it is your definition, you would have to act on the definition. 0.861 is the smallest number. So I divide by 0.861 throughout. This divided by itself is 1. 0.8625 divided by 0.861. That should be very close to 1. So there's just 1 there. 2.5875 divided by 0.861, they give me 3.01, give or take is 3. So what can I say? Calcium 1, silicon 1, oxygen 3, CaSiO3. This is actually calcium 2 plus, SiO3 2 minus. Silicon is below carbon in the periodic table. This is called, well, if CO3 2 minus is called carbonate, therefore silicate is SiO3 2 minus. This will become more important in the chemistry of metals as one of the underlying case study, as well as underlying key compound that you will have to know later on, perhaps in 1 year or 2 years from now. But you got to think about relationship. Carbon is above silicon in the periodic table. This is called calcium silicate. Question 22, we have relative molecular mass. We have percentage composition by mass. So really we must work out empirical, and you're going to know relationship empirical and molecular formula. Without further ado, let's get started. So I label, I'm doing mole equal to mass over mr. Sorry, in this case is AR, because empirical formula, simplest ratio of atoms. Of course, you know the definition. After hearing it so many times, candidates should be able to define what is meant by empirical formula. And if you're not able to define, you can't blame Cambridge when it comes out, because Cambridge already told you many years in advance that candidates should be able to do this and that, and we want the simplest ratio of atoms, so we have to label simplest ratio, and we have to divide by the smallest number, which is 2.275, and then that one divided by itself is just 1. We gotta evaluate. We cannot just show the working without evaluating. Just pressing on your calculator does not help at all if you don't show on paper, because especially in structured questions, if you don't show on paper, no one will know what you have done. Empirical formula is C2H4O. Don't forget, the next part is actually the molecular formula bit. So step 2, the MR of the empirical formula multiplied by a certain factor that I shall call X, for example, is going to be the MR of the molecular formula. There's the definition, there's the relationship, how molecular formula links to empirical formula by a certain factor. The MR of empirical formula, C2H4O. Empirical is C2H4O, so this one is wrong, C and D are wrong. So what can I say? C2H4O, so there's 12 times 2. 12 times 2 plus 4 times 1 plus 16 times 1. Oops, I've done that wrong. So there's 44. So 44 times X is equal to 88. There's the MR of the molecular formula. So you can hopefully see that gives you 2. So therefore, the molecular formula is going to be C2H4O twice. So C4H8O2 is going to be the molecular formula, C2H8O2. That's going to be option B there. Question 23, so you have 14 grams of carbon monoxide. We're dealing with masses. If you're dealing with reacting masses, what I would suggest is you work out MR. Carbon monoxide with 1 oxygen, 12 plus 16 is 28. Carbon dioxide, one of the 11 or 12 simple covalent molecules, formula of which you must know, structure and bonding of which you must know, and dot and cross of which you must know. Quite a lot of things you must know, really. Anyway, so what do we have? We have 2 moles of CO, giving you 2 moles of CO2. So the mole of CO2 over the mole of CO is 2 over 2. 2 moles of CO2, 2 moles of CO. Doesn't matter which way around it is, you just follow whatever you write. I want the mass of carbon dioxide. So the mass of carbon dioxide over 44, mass over MR. At the bottom, mass over MR. What you do then is you can cross multiply and make mass of CO2 the subject. Ideally speaking, this should be below down there so that you follow through your working and you label everything. But around space down there, so I use an arrow to indicate this is the next step of the working. I will still label it because I want this as the subject. I move all of this up there. So 2 over 2 times 14 over 28. And then I move up the 44 up to the other side as well. So times 44. 2 over 2 is 1. 14 over 28 times 44. I get mass of CO2 as 22 grams. If you can get all of these in the structured questions, if you're able to show your working for multiple choice questions, you will never go wrong in structured paper. You can only do a multiple choice incorrectly if you never really master your calculations. If you never really know what you're doing, that's when you will make a mistake for multiple choice question, especially when you couldn't explain to other people how and why you get that particular answer. Question 24, balancing equation. So let's check very quickly. They're looking for which equation is balanced. You got 2 iron, you got 2 iron. You got 3 oxygen, you got 3 times 1, so you got 6 oxygen. 3 times 2 is 6 oxygen. 3 carbon, 3 carbon. This equation is balanced. You got 1 zinc and 1 zinc. You got 2 Cl and 2 Cl. You got 1 carbon, 1 carbon. 3 oxygen, 2 plus 2. Okay, so 2 times 1 is 2 oxygen there. So 2 oxygen, 2 oxygen, Here you have 3 oxygen. This equation is not balanced. Anyway, moving on to the next one, you have Mg and Mg. You have 1 Na, but you have 2 Na there, so 3 is not balanced. So you know 3 is not balanced. You know 2 is not balanced. I gotta check number 4. There's no any other way. CaCO3, so hopefully you can see the SO4. The SO4 is still around. The Ca is still around. The CO3 loses 1 oxygen to the H2 to give you H2O, and now you have CO2. This equation is balanced, so 1 and 4 is definitely correct. Oh yeah, I actually could have gotten the answer because number 3 is not balanced actually. Number 3 was not balanced. There you go. Could be the answer there without even checking number 4. 25, so you have ethyne. You don't need to know new stuff. They actually have the information given. Calcium carbide is CaC2. Information is all given in the question. You just need to know how to read the question. Volume of ethyne. Ethyne is a gas, so we're going to use molar volume of gas, and this is assumed at room temperature and pressure. It's 24 dm cube per mole at room temperature and pressure. If a question doesn't specify, it has to be these as stated in your periodic table for free. You're going to have 6 grams of water reacting completely. So we have this and we want this. So we have the mole of C2H2 over the mole of water. You have 1 mole here from the balance equation for C2H2, and you have 2 mole of H2O from the balance equation. The ethyne is a gas. The ethyne is a gas, and I want the volume of a gas. So the volume of C2H2 as a gas divided by 24. The reason why I use 24 dm cube per mole is because all the answer is in dm cube, so my volume is in dm cube. So therefore, dm cube divided by dm cube per mole will give me the mole of the gas itself. As you know, dm cube divided by dm cube per mole give you the mole of the gas. At the bottom is the mass of water. So I gotta use mR of water. There is 2 plus 16, so it's 18. So there's 6 grams of water divided by 18 because that is your mass over your mR. Anyway, I rub that out. Again, I run out of space at the bottom there. So what I'll do is I'll say the next step of the working, make the volume, the C2H2 volume, which is in dm cube, the subject. Move this up there, so equal to 1 over 2 times 6 over 18, and then move up the 24 to the other side. If you can't do this one step, I would say do it in 2 steps, but whatever it takes, 2 step or 1 step, you must get the correct same answer. If you cannot, then you will have problem with rearranging question. That's something you have to tackle and address on your own. Question 26, so I have copper to carbonate. I have masses, so it seems like I would have to calculate the molar mass of copper to carbonate. The molar mass of copper to carbonate, copper is element number 29. The relative atomic mass is 64. So 64 plus 12 plus 16 times 3, I get 124. There is the gram mass in gram for 1 mole of the substance. Now all the contents turn from green to black. So this is green. Copper to carbonate is green in color. Copper to oxide is black in color. How much you actually get? This is actual. This is actual. Suppose that we work out theoretically. So the mole of CuO over the mole of CuCO3 is 1 over 1. From the balance equation, 1 mole of these comes from 1 mole of copper to carbonate. The mole of a solid, mass over mR. So I do really need the mR of CuO as well. So element number 29, the relative atomic mass is 64. Read very carefully. mR is sum up the relative atomic mass. So 64 plus 16 give me 80. On the top there is copper to oxide. So the mass of copper to oxide that I expect to get based on 100% reaction is going to be M. At the bottom there I have 31.0 gram divided by 124. So mass of mR. So work out the mass of CuO theoretical, assuming 100% reaction. Move this up there. So 31.0 over 124 is altogether just 1 over 1 times this is just this. Move up the 80. You're going to get that. You're going to get 20 gram. So you expect to get 20 gram, but you only get 17.5 gram. So therefore, your percentage yield is always going to be lesser than 100% if it is not to completion. So 17.5 over 20 times 100%, that will give you 87.5%. The closest answer is obviously 87.50. I think the reason why they have four significant, I actually have no reason why they have four significant figure rather than three significant figure. All right. 27. So benzene is a liquid. You never heard of benzene. You don't really have to because it's given the question. Benzene is a liquid. Ethene is a gas. Molecular formula is like that. We are asked to compare something about atoms and stuff. So 1 mole of benzene, 1 mole of benzene and 1 mole of ethene, same number of atoms, same number of atoms. This is very important. Now here you have 6 carbon atom and you have 6 hydrogen atoms, so you have 12 hydrogen atoms in 1 molecule of benzene. In 1 molecule of C2H4, you have 2 carbon atoms and 4 hydrogen atoms. You have 6 atoms. I beg your pardon. In the previous question, you don't have 12 hydrogen. You have 6 carbon and 6 hydrogen, so you get 12 atoms. Here you have 2 carbon and 4 hydrogen. 2 plus 4, you have 6 atoms. If you have 1 mole of benzene, then you will have 12 mole of atoms, which include carbon and hydrogen. If you have 1 mole of ethene, then you will have 6 mole of atoms. So they do not have the same number. Same number is wrong totally. So A is wrong. Okay, be careful with your choice of words here. 1 mole of benzene and 1 mole of ethene have a volume of 24 dm cube. This is not correct because look at the question. They said benzene is a liquid. If it is a liquid, not gas, therefore molar volume of gas does not apply. So this thing, volume of dm 24 dm cube, is for gas. In fact, it's given in the periodic table. 1 mole of gas occupies this volume, not liquid. Be careful again. Both benzene and ethene have the same empirical formula. Empirical formula, simplest ratio of atoms. Simplest ratio of atoms in a compound. You have C6H6. You can divide by 6 on both sides. You can get CH. That is your empirical formula. This is molecular formula. How about for C2H4? Your empirical formula, if you divide by 2 on both sides, you're going to get CH2. CH2 is not the same as CH, so same is not true, it's different. For benzene, it's CH. You divide by 6 on both sides to get the simplest ratio of atom. You divide by 2 on both sides, you get CH2. Which means if A, B, C, and D are wrong, D must be the correct answer. Let me just check if it is correct or not. But by right, if I completely are assured that A, B, and C are wrong, D must be correct. I'll just spend 1 or 2 minutes to explain to you why they must be correct there. Okay? So the number of carbon atom in 0.5 mole of ethene. In 1 mole of C2H4, we have 2 mole of carbon atoms. So if 0.5 mole of C2H4, therefore we have 2 times 0.5, which is 1 mole of carbon atoms. When you have 1 mole of carbon atoms, it means you have exactly Avogadro constant number of atoms, which is 6.02 times 10 to the 23 carbon atoms. That's why D is correct. Question 28, coming to an end now, don't worry. Sodium hydrogen carbonate undergoes thermal decomposition, decomposed from one reactant to give you 3 products. You want to get the maximum mass of sodium carbonate, so we're dealing with masses. So the MR of Na2CO3, so 23 times 2 plus 12 plus 16 times 3, they give me 106. You want to get from 0.100 mole, they already told you the mole, so that makes your life easy. So the mole of sodium carbonate is to the mole of sodium hydrogen carbonate. Read very, very, very carefully. This is sodium hydrogen carbonate. This is sodium carbonate. Sodium carbonate, 1 mole of it. So based on what I label, 1 mole of sodium carbonate come from 2 mole of sodium hydrogen carbonate. This is at the bottom because it's at the bottom. That is from the balance equation. Now from your actual amount, 0.100 mole of this react, so 0.100 at the bottom, is already in mole, so there's no need for me to do anything in it. On top is the mass of Na2CO3, so I need to convert that into mole by dividing by the MR, mass over MR. MR is 106. So what you do then is you just rearrange your equation like that. Move this up and then move the 106 up. So 1 over 2 times 0.100 times 106. So they gave me 5.3 gram. Of course, they've given you to 3 significant figure, presumably because this value that was from predictable will have been to 3 sig fig. Also because this data was given to 3 sig fig, this is appropriate to 3 sig fig as well. Question 29. So question 29, sodium hydroxide and acid. So this is alkaline, or you can call it a base. This is an acid. This reaction gives you salt and water. This is neutralization. So we're looking at the mole of sodium hydroxide over the mole of acid. From the balance equation, 2 mole of NaOH reacts with 1 mole of H2SO4. On the top there is the mole of NaOH. So I have 0.4 mole per dm cube. I need the volume of the sodium hydroxide. Each of these is in cm cube. So I'll say my volume is in cm cube. Volume of NaOH is in cm cube. I decide here to do 10 to the minus 3. Is there a particular reason? Not really. You could do divide by 1000. It's the same thing as time 10 to the minus 3. You gotta know the meaning of these. You gotta know how to key this into your calculator. And you gotta know how to read it as for your physics and math. At the bottom, we have the mole of sulfuric acid. So N equal to CV. Don't forget, the C is mole per dm cube concentration. This is in cm cube. So 0.1 mole per dm cube multiplied by 50.0 cm cube. Convert to dm cube, so times 10 to the minus 3. Running out of space here, I've got a bit of space down there, but I don't want to really move on to another page, so I'll just flick it on this side. I don't use equal because my working by right should continue down there. So I just make my volume of NaOH the subject. Before I key in on my calculator, I rearrange everything so that I am doing the right math, all right? And then I move this 0.4 and times 10 to the minus 3 down there. Alright, so you can key in your calculator. Hopefully you can key in correctly because, well, it is your calculator. So it doesn't reflect very well if you can't key in your calculator correctly. This thing is volume and it has a unit based on how we define it. We define it in cm cube. That's why we do times 10 to the minus 3. That's why our answer at the end must be cm cube. Be very, very careful about following through how you define your unknown, your algebra. Last question in this MCQ work 2. This is basically balancing equation. So let's have a look at this balancing equation. Doesn't need to know the reaction, but just need to balance the equation. 3 magnesium. Let me just check the magnesium first. 3 magnesium, 3 magnesium, 3 magnesium, 3 magnesium, 6 magnesium, 6 magnesium, 6 magnesium, 6 magnesium. Magnesium is not a good one to start with, so I don't want to think about magnesium. Alright, so magnesium is not helpful at all. Let me think in terms of phosphorus. 2 phosphorus, 2 phosphorus, 2 phosphorus, 2 phosphorus, 4 phosphorus, because 2 times these molecules of 4 phosphorus, and I get 2 phosphorus and 2 phosphorus. So altogether, I get 2 plus 2, which is also 4 phosphorus. Not helpful at all. This is 4 phosphorus. This is 6 phosphorus because 3 times 2, I got 3 of this molecule. Each molecule has 2 phosphorus. 3 times 2 equal to 6 phosphorus. There you go. I can cross out one stuff already. Next thing, let's have a look at the oxygen. Oxygen, 6 oxygen. Here you have 2 oxygen because in the bracket you got 2 oxygen, 2 hydrogen, and you got multiplied by 3. So you have 6 oxygen altogether, and you have 6 hydrogen. 6 oxygen, 6 hydrogen. 6 oxygen balance, but here you have 12 hydrogen. 12 hydrogen. Here you have 3 times 2, which is 6 hydrogen. Here you have 4 hydrogen. 6 plus 4 give you 10 hydrogen. You have 12 hydrogen. A is wrong. Alright, I hope you know how to read balance equation correctly. You should be doing it a lot faster. You should be doing it a lot faster in your head because you don't have much time to think through this kind of thing in the actual thing as an actual chemist. What next? 6 oxygen and 12 hydrogen. So you have, just now you have 6 plus 4, which is 10. And then you have another 2 here. So 6 plus 4 plus 2 hydrogen. That will give you 12 hydrogen, 6 oxygen. B is actually balanced. Let me check and convince you that C is wrong. Let me convince you that C is wrong. Let me see. I have 24 hydrogen, so I have 24 hydrogen. I have 12 oxygen, and I can immediately see that my oxygen here is not 24 because I have 2 oxygen times 6, so I have 6 times 2, which is 12 oxygen, no other oxygen on the other end, 12 oxygen and 12. Actually, the oxygen does balance out, so I can't talk about oxygen. Perhaps I can talk about hydrogen. So let me see, hydrogen, so altogether for C, my hydrogen on the right hand side, let's count 2 hydrogen, 2 times 6 is 12. I have 4 hydrogen here, and I have 3 times 2, which is 6. So I have 4 hydrogen from here. I have 6 hydrogen from the 2pH3. That gave me 22 hydrogen. But on the left-hand side, I have 24 hydrogen. I have 22 hydrogen on the right-hand side. I have convinced yourself, hopefully, that between B and C, I would have gone to check the lower number first. Always work with the lower number first. Easier to check, easier to count. If you get it correct, this is the answer. If you don't get it correct, the other one is the answer. So be very careful about it. And, well, just checking a balance equation, right? That's it really for this work 2 MCQ. So quite challenging in some questions. As with any MCQs, you must have a reason as to why and how. I did tell you to prepare these kind of calculations by doing your working on a full scale or on a blank paper, so that you're not running out of space and you know how to practice in terms of setting out your working and being very clear with your labels and stuff, and make sure you could do your cross multiplying, making things the subject of formula, and lastly making sure you can key in your calculator. Thank you for watching. I hope that have been useful. Click the button on the bottom right to subscribe to the channel. Follow me at ptet.chemistry. There's ptet.chemistry on Facebook, Instagram, and Twitter. See you in the next tutorial video.